Hello everyone. Today we are going to solve a problem container with most water. So this is one of the most famous problem which we have seen in most of the interviews. And this problem is also a 2.0 and arrays problem. Let's try to solve this. So problem बोलता क्या है? The problem says okay, we have a container and there are towers जिसका different heights है. यहाँ पे देख सकते हो height. पहला टावर का हाइट है 1 अकॉर्डिंगली गिवन है. दूसरे टावर का हाइट है 8, then height 6, then फिर 2, then 5, then 4, then again 8, 3, 7. These are the heights of tower. अपने को फाइंड करना है एरिया विच कैन होल्ड द मोस्ट अमाउंट ऑफ वाटर. सबसे ज्यादा वाटर कौन सा एरिया होल्ड कर सकता है. सो इसके अकॉर्डिंग और एक प्रॉब्लम ये भी है कि हमें ओवरफ्लो का भी ध्यान रखना पड़ेगा. जैसे यहाँ देखो, इस टावर का हाइट है 8, इस टावर का हाइट है 7. तो द मोस्ट अमाउंट ऑफ वाटर इट कैन होल्ड इज अप टू हाइट 7. अगर ये वाटर 8 गया तो यहाँ से ये ओवरफ्लो हो जाएगा. नाउ लेट्स सी हाउ वी कैन सॉल्व द प्रॉब्लम. यहाँ पे मैं पहले से ड्रॉ किया है. देयर आर डिफरेंट टावर्स एंड ये जो है ये है इंडेक्स है इन टावर्स का. जैसे फॉर टावर 1 इंडेक्स इज 0, टावर 8 इज एट इंडेक्स 1 एंड अकॉर्डिंगली. सो द वेरी फर्स्ट थिंग करना क्या है, अब एरिया फाइंड करना है. सो एरिया फाइंड कैसे होता है? सिंपल थिंग, ब्रेथ इनटू हाइट होता है. सो सबसे पहले एक इंडेक्स रहेगा आई विच इज एट द फर्स्ट 0th इंडेक्स, और एक इंडेक्स रहेगा j which is at the last index, let's say n minus 1. So it is at 8 index we have j, and at 0th index we have I. Now let's say we start filling the water. So कंडीशन क्या चेक करेंगे जब हम फिल करेंगे वाटर को? वी नीड टू सी द मिनिमम हाइट वी नीड टू स्टोर. सो 1 और 7 में मिनिमम हाइट कौन सा है? 1 है. सो अप टू हाइट 1 वी कैन फिल द टैंक. सो हाइट 1 पे टैंक फिल किया तो till here the tank will be filled. So the height is 1 into height into breadth. What will be the breadth? Breadth will be j minus I. That means j, which is 8, and I will be 0. So 8 minus 0 will be 8. So 1 into 8. So we got the area, the container, the area of the container will be 8. So what we're going to do? We're going to create a max variable, and we will store this 8 in the max variable only. Okay, we get it. Now how we will move I and j? So which one is the smaller tower? This I. So we will move I by 1. Now we are at index 1, the height of the tower is 8, and j will be at the same index. Now you have to find which one is the smaller tower. 7, so the height will be 7. We will fill the tower water till height 7. Okay, we'll fill it. Now we need to find the breadth. So j minus I. J is at index 8 and I is at index 1. So 8 minus 1 will be 7. So we got the answer as 49. So okay, this one is greater than 8. So again we will store this 49 in max variable. Now we got our answer as 49. Now we will again move. Now which one, tell me which one is the smaller tower? Again j is the smaller tower. We will move j backward by 1. Abhi 3, and again I will be at the same index. 3 and 8, which one is the smaller tower? 3. So the height will be 3, and we will fill the water till height 3. So we'll fill the water till height 3 only. And for the base breadth, what we're going to do? J minus I. So 3 is at index 7 and I is at index 1. So 7 minus 1, 6. So 6 into 3 will be 18, but it is not greater than 49. So again we will move. Now which one is smaller? J is smaller, so we'll move J backwards by 1. Now you can see the tower is 8 8, both are of the same height. The height will be 8 only. Now we'll fill the water till the height 8. And what will be the breadth? J minus I. Again J 6 and I 1. 6 minus 1 is 5. So 8 into 5 will be 40, but again it is less than 49. So in that case our 49 is again the greatest answer. So since both I and J are of the same height, so I'll move J by 1 and I as well by 1. That means if both heights are same, in that case I need to move both of them. Now J, we have 4 height. I, we have 6 height. Which one is smaller? 4 is smaller, so the height will be 4. We'll fill the tank till height 4. And for the breadth, again J minus I. J is at index 5 and I is at index 2. So 5 minus 2, 3. So 4 3s are 12, which is again less than 49. Now we'll move. Which one is smaller? 4 is smaller. We'll move J 5 and 6. Which one is smaller? Again 5 is smaller. The height is 5 and we will fill the tank till height 5. Okay, we filled it. Now again we need breadth J minus I. So at 5 we have index 4. At 6 we have index 2. 4 minus 2 is 2. So 5 into 2 we got 10, which is again a smaller one. Which one is smaller here? 5 is smaller. We will move our J by 1. Now again between 2 and 6, which one is smaller? 2 is smaller, so height is 2. We will fill the tank till height 2. J minus I, which is 3 minus 2 1, so the height is 1 and this is 2 only. So how to code this? You may get the idea how to approach this question. Let's try to find out how to code this. First, let's store the height. Now we know we need two things, an I variable and a J variable. That means basically we need two pointers. So let's name this as left and right. The left is starting from the 0th index and the right is starting from the very last index, which is n minus 1. Now you know what we are doing. For the height we need to find the smaller tower. You get what I'm trying to say? For the height we need to find the smaller tower because we doesn't want the water to be overflowed. So that's why we'll fill the water till the tower of smallest height. So first we'll try to find the height. Now that's it. Now what do we need to find? We need to find the breadth or the width. Let's call it width only. Now what is the width? Width is simply right minus left, basically J minus I. Now we need to find the area. How to find the area? Simple, height into width. And one more thing, we need to find the maximum area because we will going to get different areas for different towers. But what we need to store the maximum area. For that I'll be creating a variable max, and let's find math.max max comma a. Now we know we have find the maximum area, but one thing, we need to move accordingly. If we have a smaller tower, then I need to move one forward, one backward. So how to do it? We will be writing a while loop which says left is less than equals to right. If height of left is less than height of right, you may see here the left part is smaller. So in that case, we need to move a smaller part, which is left by one position. Else, oh sorry, else if height of left is greater than height of now you may see the height of right here is smaller. So we need to move right by one position. Since right is at the last index, we need to move it backward. That's why I'm writing right minus minus. Else, there is one condition as well where both of the towers height is same. In that case, we need to move both parties. That means left pointer and right pointer by one position. And at last, what we need to return? We need to return the maximum. So let's try to run. Okay, there is a issue. There is an spelling issue here. Now, okay, there is an issue here. Let me try